Introducing the brand new Rock mobile mount. So today I want to introduce you the brand new Rock mobile mount, and I want to show you the mobile mount. How does the R3 Pro connect to the mobile mount? And we're going to go outside and install it on my car. And I'm going to show you how all that works. So right here, this is the new mobile mount. It comes with everything you see right here, as well as what's in these two baggies here and here. These are some standoffs, as well as a tether, and then your GPS cable that goes from your antenna to the R3 Pro. Now, if we take a look at this, we have four very sturdy legs. Look at these guys, very thick. I'm a big guy. I think if I tighten this thing down all the way, and if it was on something really secure, I don't know, it might hold my weight. I don't know. These things are huge, so I wouldn't actually hang from it. Don't do that. But then you get four of these suction cups. So you can configure this and suction cup it to your car. I mean, you can do it on a boat. Anything that has a smooth surface those suction cups will adhere to well will work. Just make sure you clean those surfaces beforehand. Use some Windex, make sure they're clean. So you can loose them, you can reconfigure the legs, lock them down wherever you need. And then the way these suction cups work is they just have this little orange. So you put it on that surface and start pumping it down until the orange disappears. Once that orange is gone, that's when you know it's full suctioned. A couple other things that I really like about this is this is the exact same antenna from the Rock base, and this actually allows us this fixed lever arm. So now whenever the R3 Pro is mounted on here, which I'll do really quickly, just in a second, you'll see there's always a fixed lever arm. Meaning, like when you do calibration, we know the distance from here to the LiDAR very well. So all this, calibrating stuff for the lever arm, not that big of a deal. We know what it is. We've measured it here at the factory before we sent it to you, and that works really well. So let's talk about the other thing that you need to make the mobile mount work. The Slam Dock version 2, and it has the 360 camera on here. So you can do colorized mobile LiDAR data, which is awesome. And also you get the photo spheres from this as well. So inspection photo spheres. You see here on the side, we have the GPS connection. This is power for the 360 camera, and then power that connects into the power brick that comes with it. So we have four of these screw attachment points, as well as the center one here. And we're going to use these four to connect it to the mobile mount. Hey everyone, and welcome to our live stream launching the new Rock mobile mount. So don't forget, this video, actually, that was a video. This is me live now. That's going to be all available online. We have a whole installation guide, kind of goes over how to install the mobile mount. So stay tuned for that. I think we're going to release it later today, and that's going to be part of the onboarding, as well as everyone to watch and learn about the new mobile mount. But now, today, you guys are joining me. I actually have the mobile mount here. We can take that off. Perfect. And so here we go. This is our sturdy, dirty mobile mount. And with that Slam Dock V2 and the Colorized Slam on there, which is actually Colorized mobile mount. It's heavy. I'm not going to hold it the whole video. Like I said in the little video you just watched, it's heavy duty, and it's going to suction cup to your car. I actually went out and captured a data set yesterday, and we're going to jump into that in just a second. We're actually because I just captured this data set for this live stream, and we're processing it right now. It's at 94%. It should be done in a second, and then I'll show you that. But let me talk to you about a few things about the Rock R3 Pro V2 that came out and this mobile mount. So if you're not familiar, a couple weeks ago, we just launched the V2 with the Rock R3 Pro. And in the V2, we did upgrades to all of the IMU, the GNSS, the onboard computer, the LiDAR, as well as all the desktop software. What the result of all that means is that the point cloud from the Rock R3 Pro V2 is now incredibly more accurate. It's really phenomenal. And we're offering a route for people that already purchased the V1 to upgrade into the V2. And this is all part of the Rock ethos, what we're trying to do. We believe that your hardware should improve over time, and that's what we're trying to make happen. So we believe that we're following through on that goal by giving this big, massive upgrade from the V1 to the V2 and enabling people to upgrade their V1 to the V2. Anyone that buys a V2, it's already a V2, so no need to upgrade today. But that's a part of our ethos here at Rock, is that we want to capture the world in perfect 3D. We want to give you the tools, and we believe that your tools can get better over time. And we're building software that makes it get better. We're changing firmware inside of these units to make it get better as well. And then wrapping that all together with simple, easy to follow instructionals, tutorials, support, as well as getting you deliverables from your data with our Rock Pro Services team. So end to end. And one thing I want to talk about that, we have great hardware, great software, and great pro services. You can actually use all three of these together, all three of them independent, come in, on step 2, leave on step 1. All of those are available with Rock. You're not locked in to anything. We make great tools that we believe you should choose to use because they are the best. But if you had a different LiDAR, you can still use the Rock Cloud, and you can use our pro services. If you have a Rock LiDAR, you don't have to use the cloud, and you don't have to use pro services. You can just use the LiDAR, get your data, and go somewhere else with it. We still believe that our solution is the best, and when it all comes together, it makes a seamless workplace environment for you to get your job done and get reliable deliverables from this new technology as you integrate it into your workplace. So anyways, guys, that was a bit of a mouthful there. But I want to talk more about the mobile mount today, and that's what we're here to talk about. And so this mobile mount is very, very sturdy. So it's got these suction cups, and it will very adjustable, so you can kind of adjust it to anything. One of the things I really like about it is the fact that it has this fixed lever arm. So lever arm means the LiDAR goes right here, and the distance from the GNSS, or the actual antenna, to the LiDAR is fixed. And so it helps you get more regular, accurate data every time when you process. The processing of the data is the same as aerial data. So actually you're able to get the data, and then it is stored on a USB. Here, I got one right here. So I don't know if you guys can see that. And then you take this and your base station data, and you process that on Rock Desktop. The other cool thing that happens is because of this 360 camera on here, turn it so you guys can see, it colorizes your mobile data too. And not only does it colorize it, but we generate these things called photospheres in this new product we're calling Rock Inspect. So Rock Inspect gives you the full 360, it's kind of like a Google Street View, where you go from one 360 photo to the next one, and it allows you to see that visible data as well as your measurement data from the point cloud. So it's pretty darn awesome. Let me check in with the team. So it looks like it is still processing. I have another data set that I can go ahead and share with you right now. So let's go ahead and pull that one up. So this is your first look at colorized mobile data. And this was just driving. I think I was going anywhere from 20 to like 40 miles per hour on this whole thing. Side note, I was using the full self-driving on the Tesla. So actually, the car was driving itself. And don't tell people, but I was definitely using my phone to record a video. But the car was driving. I was capturing mobile LiDAR data and recording a video. 2024, y'all. Things are different. So we're going to kind of show this data set and just move around. We got some of these curve features. And then I'm going to go over into the intensity gradient view here in a second, so you can actually see what it looks like. Now, on all these colorized data sets, no matter who makes these things, you're always going to see some white on the leaves, and that's the sky. That's the sky's background bleeding through. And I think every product I've ever seen has this, and ideally, one day, we will master it, and that will never be visible again. So, really beautiful colorization of the point cloud. But I think the more important thing, well, nothing is more important, but coming over to the intensity gradient. And so a couple things I want to point out with the rock mobile mount system. So one is talking about overlap. Oftentimes what you're going to see with mobile mapping systems is that when you do overlap, there's going to be a vertical separation happening. Let's take a look at what we're seeing with the R3 Pro V2 on the rock mobile map. The white line, that is how we drove. That's our, trajectory. And so we actually have overlap happening from the left and right. And I don't know, this is actually my, I looked at this data set about 10 minutes ago. So this is still one of my first times looking at it. So everything looks pretty darn good. I want to look at curbs though too, because curbs are important. I want to see, like, can we drive really quickly and pick up curbs? And we're going to take a detour because now I get sidetracked looking at the intensity gradient of this railroad crossing. And we can see here, if we were to look closely at so what's happening? Why is it green and red and blue? What's really going on? The laser has a spot size, and where it's blue, that's because the laser shot and cast a beam on this blacktop. This is not as reflective, and so that is the intensity of light that came back to the sensor. Here in the red, that's where that white painting is at that you're familiar with on roads. But the green is where actually half the beam was on the blacktop and half was on the white. So that's actually like a 50%, intensity. So you can kind of see the alignment of the system when you look at that, when you see those characteristic green outlines of these data sets. This is really, really cool. There's a curb right here. Why don't we just jump in and start looking at this? I think this one actually is one of these like sloped curbs. So if you hit it going 40 miles an hour, it's not going to be a full blunt stop. But why don't I come on over here, look at some of these signage. I think this looks beautiful, guys. I'm actually surprised that it captured, because I'm pretty sure I got stopped. You can actually, yeah, you can see it. So you can see this, this was moving because I got stopped and a train came through while I was sitting here. But let's just take a look at some of these curbs and the features here. I mean, that looks as I would expect it. Pretty much straight up, almost straight up, straight down. Got some ramps here. Something was placed there. We got these beautiful trees. Also some grass growing on this. Some beautiful signage. Someone on their bike. Now, let's talk about this for a second. So one of the problems that people are faced with in capturing mobile data or even in SLAM data is moving objects. So this was a person on a bicycle here on the left-hand side. And coming out in the next couple weeks, Rock has a very robust moving object filter. So it will remove all of those moving objects. And so your data set in a couple weeks, this should all be just automatically classified and removed and giving you a much cleaner data set. You can see if it was like the middle of what's that crossing in Japan that has the busiest intersection in Tokyo. If you had that, there'd be a lot of people moving, and so a lot of noise. But using the moving object filter, we're able to get rid of that noise. A couple of things I'm really excited about doing with this data set is some of these ADA compliance issues. So looking at slope of these pedestrian paths going to the sidewalks and being able to pull that slope directly from this data from the Rock R3 Pro V2 on the mobile map. Very excited about that. I'm also very excited about being able to take this data and merge it with aerial data. This is all GPS registered, and to be able to merge the aerial with the mobile data, great use case. And then third, we have our augmented algorithm, which is in beta right now, and will be coming out, I think, in full release here, hopefully within the month, where it actually is a hybrid SLAM GNSS algorithm. And so what that means is, when I'm testing this right now, say I were to go driving and I drove straight into a parking garage. You lose GPS signal. I'm trying to find a parking garage. I know there was one around here. This is actually, side note really quick, this is Lockheed Martin facility over here, and this is all the Google Cloud campus. That's where I went driving yesterday. Really pretty. Back on topic. the augmented SLAM GNSS algorithm, which enables you to go directly into something like a parking garage or a tunnel or under a heavy tree canopy and maintain the 3D accuracy now going over to SLAM. So all that in the seamless transition back and forth is going, we're in beta right now, and hopefully it's going to be full release by the end of next month. It's April 25th right now. So that's our goal. We'll see if we hit it. You know, we always strive to hit these goals, but I think the guys are doing it pretty well. And so I think the really unique thing too is how easy it was for me just to put this on my vehicle and then just start driving. And so we can take a break and talk about that for a second. So how do you collect data? And I think it's an important thing to know, and I want to share with you how I did it. So we can go, leave the data set up, but do you want to go 50-50 screen with me, Patrick? Yeah, that's good. So how to collect data. So in the GNSS mode, so it has the GPS on the mobile mount here. What we're going to do is we're going to install this on the vehicle. We'll set up a base station, or we'll use a rock base, and so that those are already set up if you use one of those. And you're going to start collecting data. So there's one button on the R3 Pro, and you start logging the data. You sit static for 30 seconds, don't move. Then you do 5 seconds in a straight line, and then 1 figure 8. Let me show you on this data set. Let's bring the data set back full screen. That's exactly what I did right here. You can see I started right here. I sat for 30 seconds. I went to a straight line, and then right here I drove this almost figure 8. It was pretty close to a figure 8. It's pretty close. And then I was off and mapping. And we can look, and I came back in later in the trajectory, and again it should be all lined up nicely. Yep, no separating. So that's a big issue, guys. In most mobile mapping systems, you get a massive separation on the vertical. Anytime you after 20 minutes of driving, you come back over a spot, there's gonna be like 2 data sets. So that's something that we really worked hard to fix. So that's really a robust feature of the R3 Pro V2 with the mobile mapping system. And then further augmenting that with our SLAM algorithms is going to be, like I said, it's in beta, but that's really the ticket. That's what you want. So that's how you collect it. 30 seconds, straight line, figure 8, drive and collect. Come back, straight line, sit 30 seconds, turn it off. Now, the camera on board, let's come back to me. This is that Insta360. And one of the things about it has about 3.5 to 4, I think it's like 3.5 hours of video capture time. So that's the one thing you have to be cognizant about. About 3.5 hours of capturing data before you need to pull over and change out that memory, clear out that memory of the camera. That's the one limiting factor. The memory that's on the R3 Pro, this is going to be fine. It's 256 gigs, and actually it's fine almost all day. I mean, it holds a lot of data. So the camera is going to fill it first. That thing shooting 6K video, and so that's really cool. Something else about the 6K video is that the video is being chopped up into the photos to colorize, and then getting those inspection photos. And then we're also going to build in some functionality to really scrub through video by location. So that's going to be coming soon. But for now, the inspection photos are really, really impressive. Why don't we give me a second and let me ping the team here and see if it's still, about another 5 minutes on this next data set. So why don't we open up the floor for some questions and see what you guys have, if there's any questions out there. I know a lot of people might be at AUVSI right now down in San Diego. We are not there. We do these live streams, and I really like talking to as many people, and I'll be honest, I got COVID like every single time I go to this. So I've had COVID 5 times now. So I don't know. I get that thing. Are you experiencing issues where the 360 camera wobbles? It seems like it's levering out from the mount. No, this is not at all. Like, not at all. That was me, like, literally. I'm going to break it if I go any harder. But no, it's not wobbling. We do have an alignment process for if you were to take the camera off of the mount, like disassemble everything and then put it back together. So there is like a calibration feature that enables the camera to be aligned to the LiDAR. But once you do that once, it's pretty solid. GPS antenna comes with rock base. It does. It's the same antenna. Yeah, this thing works really well. It's a triple band antenna. Works really good for the rock base. So we're using the same one on the mobile mount. And this is basically a survey. What was that? 5/8 inch screw down here. You can see on the bottom here. And actually on the bottom, you can see that the little bent piece there, that's separate from the main plate. And the reason we did that is because we foresee the future of what you guys will be doing with this. And naturally, you're going to mount it to something, and then the GPS is not going to be straight up and down like that. Maybe it'll be tilted forward. So you're going to grab this bar and just bend this piece here. We don't recommend doing it, but we built it in such a way that those pieces are easy for us to replace. So if you did mount this and the antenna was like that and you bent that piece in order to make the antenna go straight, so I bent that backwards and bend that piece of metal down there, then you can easily just replace that. You see? Yeah. It's going to happen. I already know it. In fact, I've already tried it out. How did you fix the vertical offset? Well, a few things. In the GNSS with the V2 upgrade, we did a lot of work on the quality of the actual GPS chip in there. You know, you're measuring all these signal to noise ratios, you have multipath rejection, all this stuff happening on the chip level. So we dug really deep into that in order to get just basically better data inherently. And we sample faster, and that's probably the biggest improvement. So better data in, better data out. It fixed the problem. And then also augmenting it with our SLAM algorithms has been kind of the real big breakthrough, I'd say. So that it's like the SLAM GNSS thing hybrid. It brings that tightly together. If I tried mounting on a pickup truck cab, seems set up for a car. You can do it. Yeah, you just suction cup it probably on the tailgate. Maybe I'd go off the rear, whatever the quarter panel, the fender, what's that called? So probably go truck bed, and reach across the other side and go in the corner of the vehicle. And maybe try getting two over there. Yeah, I think that'd be fine. If not, you need to get like a hard top or something. I think it'd be fine. Personally, I've done it on a couple vehicles. We were talking about me just going to a mall and just while people are in the shops, just go around to every single car, take photos of how to install it and everything. It was vetoed by the rest of the team. All right. Well, yeah, going multiple passes when going fast. Yeah, it definitely helps. It fills in data. It does get surprisingly well, and I'm gonna go out and test a few things. I haven't done the highway yet with it. There is a oh shit strap on here, so make sure it's just a tether and a carabiner. Make sure you just tether it to your vehicle. Yeah, multiple passes does fill in, and the other thing that it does as well is because this is like very accurate but economical as well, and that's really what we're going for. Accurate and economical, because the $1 million systems have like 3 lasers on it, and they're going to be at 2 different angles like this, and some of them have a third one up top, and that's to make sure you get coverage, right? So you're getting everything. So sometimes when you drive forward here, I'm going to come back to the data set. Let's see, like you'll see one direction of an object. Like I see this direction of this object, but I don't see this direction of these objects. So if I drove the other way, I would also see the opposite side of that building too. So it's just filling in. Everything's straight lines, right? So accurate, economical, you might have to drive there and back. All right. While we are on the topic here, let's look at some down and back areas and see what it did do. Go ahead and bring the data set back, because I think that's a good point here. So here I drove down and back. Let's see what kind of effect it has. I can actually go by GPS time and slide it. So you can see here I drove. Actually, let's do this first. I think this is going to be cool. Let me start here. So I can slide the GPS time, see where it's driving, where I'm driving. Then I sat here, went straight, made a turn. Here, realized that road does not go through, pulled a U-turn, turned back out, came around, and down, and back through. So it's a big, all of this is overlap. And this is like a big divided area as well. So I think if we just look at this, so you can see that's what one pass would look like, right? So let's let it load for a second. So you can always click this change view, and there's a performance. You can go to quality. That's the point. That's how many points are visualized on the rock cloud. So you can see we got a gap here, right there, where it's not seeing over, and then it sees the other side. Why don't we look at this side, and we bring the GPS time and drive over and fill it in. So, original question was highway speeds, multiple pass and highway speeds. Does help. But even when you're just doing regular stuff, because of the geometry, sometimes you need to go there and back to kind of fill in everything. I see Dave Baker's question here. He meant the tailgate. He would have to bend the antenna about 90 degrees, I think. Yeah. You can do it though. And honestly, that's if you can go off the tailgate and do the 90 degrees, so that means the laser would be basically pointing almost straight down. You're going to get the highest quality data for accuracy. It's like a profiler at that point, because where does inaccuracy come from on these mobile systems? Well, if you have the LiDAR just mounted on your roof and pointing straight out, in every direction, just horizontal, well, the laser beams are going way out, and basically it's a spot, and so you're getting these glancing angles where the light just kind of glances off the road surface, and so there's a big uncertainty to where exactly that, because there's only one return going to come back from that, but where did it actually hit the ground? So that's when you'll actually see if you were to take the LiDAR. We pre-programmed it at this almost 45-degree angle, but if you went all the way up to horizontal or parallel with the ground, the data gets noisy really far out because of that uncertainty. But then as you bring it straight down and you're pointing right down at the road, well, then you're always seeing almost nadir on the road. That's going to be your most accurate data anyways. And then if you have a curb, the laser will spin, come over, and hit that curb as well. So very accurate with that scenario. Do I test for accurate GCPs? I, of course, do. We have some videos coming up on that. So absolutely. GCPs, total stations, all this stuff. What I've been doing actually is using the Rock Base Network, because we're sitting there. Basically the way the Rock Base Network works is that we have the high-end GNSS, and we let it burn in for about 7 days. And then we take that whole data set and run like a massive Opus solution on it. Okay, I just got feedback. They're uploading photos into my data set right now. Cool. Yeah, I think there's going to be a lot more coming from Rock on the inspection portion of things, on the mobile mapping, on just how to go easily from 3D data to photos and do annotations, road conditions, all this stuff on the photos to the actual 3D data, and how do we make workflows that make it easier for you to use. So that's going to be like our kind of guiding North Star on this. So I think that's going to be very exciting. All right, let's get another question. I see there's some more. Yes, give us 1 second. That's what they're preparing right now with me. I'm going to see if, let me refresh my screen. Okay, why don't you can share my screen again. So this is what it looks like when you have the inspection photos loaded on your project. So in a Rock desktop, you can select every however many meters. So it's by distance, and that also, so there's also a masking feature too that masks out your vehicle back in. So that's actually what they're running right now. Because I, like a fool, went out and just randomly didn't follow our own instructions. Naturally, that's what I do. And so in this, you can see the back end of the car there, but you can just mask that out and then it doesn't show up in the colorized data set. And that's what they're running right now. But this is the inspection photos. So you can come in here and click on one of these and that opens up the viewer at that location. And so there's the car and that's the back end that you mask out. Actually, let's see if I can make this bigger. You can always just drag this over and go bigger. Enhance. Show me paint striping. Awesome. Yeah, and I want to play around with like mounting in different locations. I've done a lot of mobile mapping, and I think general purpose, this is like just right on the back like this, kind of pointing down, has been good. Obviously you can do on the quarter panel and kind of go at an angle, then you get a little bit different perspective on things. So why don't I? Let's full screen this parking lot. But yeah, like I said, one of the visions that we have is being able to annotate on these photos and translate that directly into the 3D point cloud as well. Yeah, can you click on the photos and get coordinates? Yeah, soon, Ray. That's exactly what we're talking about. Yep, clicking on the photo and getting the coordinates directly from the photo. Soon. We're working on the back end to make it so, because whenever we released this inspection feature, it actually was backwards compatible with everyone who uploaded data in the past. So that enabled everyone to get this. So we're trying to make sure that we cover all the cases. So that way, whenever it goes live, it works without working on 10% of data sets and breaking on everyone's data sets. So, you know, it's always a challenge, but you know, that's why we pull our hair out doing it every day. Awesome. Has he actually improved in turning around corners? Yeah. Yep. So the same thing I showed on that video with the R3 Pro V2 launch, the corner accuracy on that, it translates directly into this as well. So it's the same result. So now it is all good on the corners, all aligned, as well as even on the give me a second. I'm pulling up some stuff. Like how you see grass growing through this parking lot. So this is me doing figure eights, driving in circles here, right? So this is a lot of high velocity corners turning around. Let me move that over. You can see it's all lays down. So we look at this corner too. Let it load for a second. Sometimes I go too fast and people can't see anything. Probably easy to see on this vertical feature, because if it was like spraying going up, you would see the top of this fence would get triple or quadrupled. You'd see it really expanding. All right. Well, guys, this is the, I'm gonna refresh that. Let's see what happens. Oh, there we go. There's some more photos they're uploading. I like how they're uploading it right now as we're playing with it. Yeah, if you guys are curious about Google's campus here, these are all the Google bikes. And there's a nice cafeteria right over here. Actually, yeah, in this building right there. Great place. lots of buildings, lots of people working there, and really awesome to be so close to it. All right, let's bring me back full screen. And so guys, if you're interested in the mobile mount, let me do a couple shout outs for what we're trying to do. So there's this live stream that you're in right now. Thank you so much. I really appreciate you taking the time to listen to me talk. I know it's not the most pleasant experience for everyone, but I hope you get some information about it. If you're interested, we're doing a couple new things. And one of the things is we built this Indiana Drones channel, right? And we built this company, Rock Robotic. And one of the things that we really believed in to start with was being one to many, working in the open and enabling others to win. And so this actually bleeds through every piece of our company and everything that we do and how we think. So I think it's really important to understand how we think. And once you understand how, you'll understand the why and you understand the what. What's going to be last. So because we do that, we are starting to do these new, so people are interested in purchasing products, sales calls. We're doing group sales calls now. And what we want to have happen, and this has been really successful, is not only do we want to talk to you, but we want you to talk to you. So you talking to the other yous out there, not just rock people talking, one to out and just like I'm doing right now. And so we have these sales calls. I'm doing them on Mondays, Tuesdays, and Thursdays, and we're, it's a more, a nice, quaint environment, so you can feel comfortable. Small group, you can talk about your needs and your questions, and we dive into it. It's been, we let the message know of what we do at Rock, and then we get into some data sets, and we actually see customers talking to customers, and our clients talking to clients, and it's been really nice seeing like the connections. So this one to many, also, enabling others to win, that's kind of the checkbox there. We're committed to always providing the video content, teaching you. So we have the Rock Academy for people that are customers, and we have more videos coming out on the mobile mount for that. And yeah, just reach out. We're going to keep doubling down on this mission. And we believe, like I said at the beginning, we're trying to make the world capture everything in perfect 3D. Whether it's from the Rock Base network, so our GPS, RTK network work that we do, our LiDAR systems, our software, or our deliverables, kind of the full end-to-end for your 3D workflow and workplace. So am I getting pinged right now? Someone's correcting me. Okay, no, just said I can refresh and show more photos. I already showed enough photos for you guys, but I want you guys to go ahead and reach out to us. Stay tuned. We have more of these live streams coming up. Hope it's a valuable time for you. I'm going to give you back another 20 minutes of your day and let you reach out to us if you have any other questions. So with that being said, I'll catch you here next time. See you later.
Ready to dive into the future of mapping? We've got a whole series of live webinars planned on rockrobotic.com where we'll deep dive into our products and services, showing you exactly how they're going to radically change your mapping projects. Don't miss it. Ready to dive into the future of mapping? We've got a whole series of live webinars planned on rockrobotic.com where we'll deep dive into our products and services, showing you exactly how they're going to radically change your mapping projects. Don't miss it.